Hello everybody, this is a maths methods video, not a spec one, and we're going to find the tangent to some function if we know the equation of the function and if we can find the function's derivative. So let's have some function which is going to be f of x, and we have to know the derivative of the function which is f prime of x, right? And the important concept to remember is that this is the slope of the function at position x, and because x is our entire axis, it gives you the slope at every single point. Now, if we take some drawing of a function, it doesn't matter what this function is, but drawing it just helps you visualize it. We grab some function, let's say it's like a cubic of some sort. Now, we want to find the equation that will give us a line tangent to a point. So if we get a point, then we have a tangent line to that point, and we want to find the equation for that line. And let's call that t of x. Tangent, actually not t of x, t of a. Tangent at some point a, because this doesn't, because where x is for the entire graph, we're looking at a specific point of this graph. So if we have a look at where that line is, the distance from the origin is a in the x direction, so you move across a to find that point. So t of a is the tangent at point a. Now, we know the equation of a straight line is going to be y equals mx plus c, yeah? That's the standard equation. Now, in this case, m, remember, is the slope. And what do we know the slope to be? Well, we know the slope at any point. We're going to have to pull back this equation, so it's going to be f prime, not x, but only our specific point, a, because that's what defines a slope. That's what a derivative is. It's a slope at a point, or slope along the entire graph, but since we're just looking at a point, we can find it. Alright, so we figured out the slope. Now, the tricky part of this equation is this c bit. We need to find where does this tangent line intercept the y-axis. Now, the great thing is if we look up close in this section, we can have our green line here. We have our y-axis here. X-axis going all up there. Our point here doing something or other. And we can have our tangent, but let's just ignore that for the moment. Well, what we can do is we can find how high this is off of the x-axis by measuring. So we can measure this height here as our h, and the height h is going to be equal to the function at point A. Because remember, there's a function that lies through here, that are nice tangent graph like that. The function at that point. So since we can find the height of the function at that point, we can find that value there. So we can start constructing a bit of a triangle. Start constructing something there. Now, to figure out that height there, we need to figure out how much it drops as we move across the distance back that way, which we can call, since we're moving backwards, minus a. So we move back to the origin, so as we move back minus a, how much does the graph change? Well, we know from most triangles, or from slopes in general, that if we move across 1 in one direction, and we move up another value, let's say 3, and that's what defines a line with slope 3. It's how far it moves per unit 1. So, to find how far something moves per a, then the change of it is going to be a times the slope. So since for 1 it changes by the slope in height, it changed for a, it changed by a times the slope in height. It's just a scaled up version of that smaller triangle with 1 and the slope. Right, knowing this, we can find another value. Let's call it our change in height, or delta h. So from here to the x-axis, we can find another value, delta h. And delta h can be given by the function of minus a times m, and we found before that m, our slope, can be given as f prime of a, so we have minus a times f prime of a. So our y-intercept is going to be this, it's going to be these two combined, isn't it? Because we've got a drop here and some more here, or it could be up the other direction. But we know our equations. We found delta h equals minus a f prime of a, h equals end of f function at position a. So we know that our c value is going to be the function at position a minus a times function with the derivative function at position a, which is useful because now we've got our c value and we can substitute into the final form of this equation. Take this back up the top, then we can find the equation which is going to be given as a y equals slope, so f prime of a times x plus our c value, so f of a minus a times f prime of a, and that will be our equation to find the slope and equation of a tangent line at any point A.